And hey everybody, welcome to the Daily Space Weather. We've got a sunspot apparently formed as an active region rises around the eastern equatorial region, as well as a gamma ray burst. I'm your host Dan, aka smAsho. First thing we're looking at here is a composite image of the sun, complete with some lunar transit interference. We're seeing some missing data. The Integrated Space Weather Analysis website is down. Here's 335, 193, and 94 angstroms. And you can see a lunar transit right here at the beginning, covering up part of the solar image there. And here's a full disk view in 171 angstroms. No views from Lagrange point 5 today, the radio flux of the 10.7 centimeter variety, otherwise known as the 2800 megahertz radio flux, still at 73. There's the 1 year chart of that from solon.info. And for you new viewers, the radio flux, the 10.7 centimeter radio flux, is directly proportional to sunspot number. So we've got some HelioViewer movies for you here. Here's a little bit of data, including 304 angstroms. And the LASCO C2, we don't see any ejecta on the LASCO C2. Here's a more close-up image of the sun in 304 angstroms. If I had to guess, I would say that plasma filament in the southeast is still intact. And you can see that right there. And here's 131 angstroms. Here's the active region I was talking about. There is a likely sunspot about to rise, and actually one has formed right there. We saw some umbre while I did show prep. I'll show you by the end of the video. First, we'll do a smash lights segment. We've also got coronal holes in the offing to show close-ups of. So I would invite you to branch out into alt tech, follow me on social media, maybe check out the Twitch app. They've got a great mobile app, and indeed the streaming platform is fantastic, twitch.tv/smAshomash. Don't forget to check out our own websites. You can find our social media there, smashomash.com. Today's featured product is the Condensed Matter Matters t-shirt in Blaze Orange, because nothing says don't run me over or shoot me like a Blaze Orange t-shirt. Condensed matter matters. Start a conversation with your friends and foes about how the sun is likely made of condensed matter, not a gaseous plasma. It explains all kinds of things, such as fusion. We'll talk about it momentarily. Please take a moment to press like and subscribe if you enjoy the content on YouTube. Press the share button. Press the notification bell. Perhaps you'll even see when we put videos up. Perhaps expect more content coming out soon. Don't forget to check out our playlists, such as smashomash.org presents the sun. A little bit underviewed are those videos. We're also on BitChute. There's exclusive content over there, such as our original Smash Hole of the Week, episode 0001, COVIDiots. And look for that playlist to be changing soon. We've got some cosmology topics to briefly touch on here. Before we do that, thanks to our patrons, the true source of funding for the content. Please consider supporting our operations by becoming a patron at patreon.com/smashomash. You'll receive perks nobody else sees, as well as warnings and updates nobody else gets. Patreon.com/smashomash. No need to roll dice today. Check out this story on SciTech Daily. Headlined, a star dying soon after the beginning of the universe could be disrupting mobile phone reception today. Talking about a gamma ray burster. It's GRB 204015A. And there's also an article on phys.org about that. It is a magnetar located in a different galaxy. We'll show you the galaxy momentarily if you want to read that article. Again, it's on SciTech Daily, as well as phys.org's Astronomy and Space section. And gamma ray bursts are massive, fleeting emissions of photonic energy in the form of gamma rays. Will it disrupt cell phone reception? I highly doubt it. But again, if you want to read about that gamma ray burst 200415A, check it out. It's located in galaxy NGC 253, and we've brought that up on Aladdin Light. There's the 2 mass. Let's check it out in Chandra X-ray. There's galaxy NGC 253 in X-ray. Great view of that. And you can see it looks like one of the poloid fields of the galaxy likely pointed toward the Milky Way. This blue part right here looking brighter than this red part here. Probably a jet pointed away from the galaxy. So yeah, NGC 253, that is where gamma ray burst 200415A is located. Also, if you haven't checked out Sky Scholar's latest video talking about lattice confinement fusion reactions, where the likelihood of fusion is much higher in these lattice-constrained reactions, talking about the likely chemical reactions happening on and in the sun. Here's a clip.
Of course, this takes us back to the sun and the hexagonal planar metallic hydrogen lattice, wherein all of the electrons are contained in conduction bands.
All the electrons are contained in conduction bands, which is very important because where all those electrons come from is something somewhat of a mystery when it comes to mainstream cosmology, and that's today's cosmology segment. Let's move on to more data. We'll show you what we've got. The real-time solar wind has been pretty steady here over the past 24 hours. Current solar wind density around 8 protons per cubic centimeter. Solar wind speed 377 kilometers a second. Otherwise, not a lot to comment on there. The KP index has been at 0 for the past 9 hours. And for you new viewers out there, the KP index is a measurement of global geomagnetism. And so, since KP 0 for the past 9 hours, let's look at cosmic rays at our favorite cosmic ray monitors. Here's the Apatity neutron monitor. You can see a downswing in the past 30 days there. Here's Barentsburg. Slight downtick at Barentsburg over the past 30 days. Next, we'll go farther south to Athens, Greece. And here's the Athens neutron monitor. Slight uptick over the past 30 days at Athens. Next, we'll go even farther south. How about Mexico City? And nearly flat, a slight downtick there at Mexico City over the past 30 days. This one you can access the archival data in, by the way. And we'll look at Oulu, Finland, and DOMC, Antarctica. There's Oulu, quite flat over the past 30 days there. And here's DOMC, a slight downtick at the Antarctican monitor. DOMBO is back to returning data. Excellent. So there's a 30 days at DOMB as well. Flat. Actually a slight downtick over the past 30 days at DOMB. And that's today's cosmic ray section. Next we'll look at magnetohydrodynamic pressure. It's the space weather modeling framework. Geospace magnetosphere movie. It's 4 hours of data. And you can see that relatively stable solar wind. Next, ground magnetic perturbations. We show it daily since we are living through a polar excursion, a geomagnetic excursion. We've got 2 north poles, and we saw a little pulse there. I'm going to bring that back. And that's actually about an hour of missing data once again, going from 8:18 universal time to 9:37. small magnetic pulse happening at that moment. Nothing to write home about. And we've brought up the 7-day graph here of the GOES proton flux to show you no proton strikes, no coronal mass ejections hitting. A small solar flare happened yesterday around 1 o'clock Universal Time, just before 1 o'clock Universal Time. Not even large enough to be a B-class solar flare, though. There's 3 days of the GOES magnetometer data. You can see pretty high readings here, actually. And here's some more magnetic data. This is gathered from 51 ground-based magnetometers, as well as ones on stereo A and stereo B, located at Lagrange point 5 and 4, respectively. And you can see the Earth is solidly in the South Pole-oriented current sheet, shown here in red. Nothing too exciting going on there. And the Earth will probably still be in the South Pole current sheet when we do tomorrow's daily space weather. So we do see this large coronal hole in the southern hemisphere there associated with the South Pole. Expect a coronal hole wind stream from that in 2 to 3 days. Also a large coronal hole in the north, rotating into the Earth-facing zone here. This one also shows you the sun's B field in blue. And here's basically the same data, also including the solar magnetogram. And we'll show you where we saw some umbrae by the end of the video. Again, we cannot access the Integrated Space Weather Analysis Center, so I can't show you the coronal magnetic field plot. Here is in-the-sky.org. I like to face my star charts to the south. If you want to know what's going on above your head, just put in your information here. I'm using the Allentown sky chart as I'm located in Lehigh Valley, Pennsylvania. I've also drawn in the ecliptic, which is this yellow line. Here's what's going on in the solar system. And there's where things will be in a week. Next, we'll talk electrons. We don't see any charging hazards. We see low levels of electron flux. There's the 1-year chart of it. And we see flatlined electron flux over the past week, as well as a forecast for continued flatlined electron flux. Looks like NOAA overestimated today's levels. There is the 3-day chart. As measured by the GOES 16, which measures the electron flux at about 300 kilometers. And this diagram shows you the F ionosphere layer. Allow me to show you my vanishing act. And that red F there on the right, that is the F ionosphere layer. The lower altitude portions of the ionosphere are known as the D and E layers. This map also shows you the penetration of electromagnetic radiation, which is those bars in the middle that says X-rays, extreme UV, visible light, IR, etc. And here's a visualization of the total electron content, showing you essentially what a GPS satellite would be transmitting to your handset through, which is through the inner Van Allen belt. And we see some anomalies here in the southern hemisphere. I'll let it play through a second time. Some minor North American anomalies there as well. Some possible GPS errors in U.S. GPS systems. And there is another diagram in miles. And so you can see essentially what you were looking at is the location of the inner Van Allen belts. The total electron content forecast. We see some power outages here. Once again, over 165,000 out of 3 million tracked customers in Washington. And another about 70,000 out in Oregon, Montana, and Idaho. Poweroutage.us. Next, looking at the ionosphere, just the F layer, or close to it. This 1 day of data provided by Australian Government Bureau Meteorology. And we see anomalies once again in the ionosphere, mainly in the southern hemisphere. So a surprisingly charged up ionosphere, and we see more of this with low levels of electron flux. And we'll bring up the latest image, this one coming in at 9:30 Universal Time. And you can see once again, we see a tripled up charge zone in the southern hemisphere. It looks almost like an ionospheric snowman. And let's continue on. Volcanoes of the past 24 include Abiko, which has been producing a 14,000-foot plume of ash. Suwanosejima is exploding. 6,000-foot plume of ash there. Merapi. Active lava dome continues to grow slow and produce incandescent rock falls. Some incandescent avalanches observed between the 4th and 7th of January. And more than 1,300 residents have been temporarily located from their homes in central Java, Indonesia, as a result of an uptick at Mount Merapi. Stay at least 5 kilometers away from the summit. Popocatépetl down there in Mexico is exploding. 19,000-foot ash plume there. Fuego exploding. 14,000-foot ash plume in Guatemala. Sangay in Ecuador. 19,000-foot ash plume there. Revenador and Sabancaya both exploding. Revenador in Ecuador producing a 15,000-foot ash plume, and Sabancaya in Peru. 27,000-foot ash plume there. Please do not attempt to pole vault the caldera. The largest earthquake of the past 24 occurred south of Mamuju. 5.7 magnitude quake there. South of Mamuju, Indonesia. And that came in just a few hours before we did the video. And let's scroll up the list and see what else happened in the past 24 of seismic activity. Really not a lot of seismic activity. And the main thing to cite here is the fact that we are seeing a massive drought of 7, 8, and 9 magnitude earthquakes. If you're in an earthquake-prone zone, please have a plan to be an asset, not a liability in the event of a disaster. Here's a 4.5 that happened near the Fiji Islands at over 530 kilometers depth. Here's another 4.5 that happened only about 40 minutes later to the west of that at Timor-Leste. Also a deep quake. And we're just going to let the list scroll up here. There's a deep quake at Bolivia of 4.1 magnitude at 240 kilometers depth. Small deep quake strikes Alaska. And the 7, 8, and 9 magnitude earthquake drought continues. Next, we'll go to nullschool.net and look at the jet streams. Here are the jet streams of the Eastern world. And shout out to all of our viewers from Unda. Leave us a comment if you're viewing from the Southern Hemisphere. And speaking of the Eastern world, check it out. We've got the jet stream blowing backwards once again over the West Pacific and the Indian Ocean. Jet stream blowing east to west instead of the normal west to east manner. Here is the jet stream scenario for the Western world. And it looks like some hot air being blown into the Caribbean right now from the equatorial region of the planet. As well as a significant low pressure system down here, not too far from the South Atlantic anomaly there. Sort of the east central coast of South America. And let's do more meteorology stuff. What's going on with lightning? I don't think I loaded that. Let's let that load and look at a real-time lightning map. And there we are on lightningmaps.org. That's your real-time lightning map. Let me just check the life of the stream here real quick. And everything looks fine. So there's a real-time lightning map. We see some lightning on northern Australia there, as well as in the eastern Mediterranean. Otherwise, not a lot to report. A little bit of lightning off the eastern seaboard of the U.S., according to the GOES 16 lightning mapper. And next we're looking at a Doppler radar image here. Pennsylvania getting some snow and some wintry mix. Perhaps some freezing rain around Philadelphia. And some storms around the north-central part of the country as well. Here's what's going on with pressure. Are you under pressure? Well, if you're in the northern Rockies, you're under some pressure. We'll advance this via the GFS forecast. There's where the GFS forecast anticipates pressure cells to be tomorrow. At 12 noon Eastern Time. And if you're wondering where we're located in Lehigh Valley, Pennsylvania. Here's a shortwave radiation map showing us where clouds are, even though it's dark. We get up before dawn to do these videos. And there's the water vapor map. Some turbulence happening in the southern Rockies there as dry, cold air collides with some moisture around the Texas stovepipe. We'll zoom in on that zone around the Oklahoma Panhandle, since it is the path of lots of resistance. And this weather pornography section brought to you by me, Dan, a.k.a. smAsho at massive personal risk and expense. It's not chemtrails. It's not contrails. It's cold air being thrust down from Canada, where it strikes into an atmospheric river, creating an atmospheric waterfall, especially in places like the southern Rockies, as we've got multiple different systems overlapping in that zone. And let's move on to our bonus features. We've got to show you the solar intensitygram, as well as the colorized magnetogram to show you a likely sunspot having formed. So let's do it. Here's the colorized magnetogram. And right there you can see likely a sunspot. Looks like it's an umbra to me. And there you can see some dark spots there. So that's significant. That one's likely to be named. It's a big enough umbra there that I wouldn't be surprised to see that one get a name there. It's got to be there for about 12 hours, which I don't think it's gotten to yet. But I haven't been watching it that closely. So let's close things out with our Helio viewer movies. Here's 193 angstroms. Again, significant coronal holes associated with both poles right now. Southerly one just rotating through the Earth-facing zone here. Here's a close-up of the northern region, as well as some shaky cam effects from the SDO. And here's the southern region, a close-up of that coronal hole. Expect a coronal hole wind stream from that in about 2 days. 2 to 3 days, I'll say. Thanks for tuning into the Daily Space Weather. Don't forget to tell your friends and foes. Share the content in your social media. Don't forget to press like and subscribe. View us on social media. Visit our own websites, perhaps pick up some merch, perhaps become a patron at patreon.com/smAsho. I've been your host, Dan, a.k.a. smAsho. Thanks again for tuning in, and may that solar wind be at your back.